When I solve an equation like this with a variable in the denominator, I want to multiply by the least common multiple of the denominators. In this case, the least common multiple is r minus 2 times r plus 2. So I'll multiply both sides of the equation by this quantity. I write r minus 2 times r plus 2, and then I'm going to write a big parenthesis, and I'm going to copy the entire left side of the equation. 44 over r minus 2 plus 52 over r plus 2. And now I have to multiply the other side by the same amount. R minus 2 times r plus 2 times 4. Now in this next step, when I actually do the multiplication, the denominators should be cleared, that's why I multiply by this least common multiple of the denominators. I multiply r minus 2 times r plus 2 times 44 over r minus 2. What that looks like is this: r minus 2, r plus 2, 44 over r minus 2. Plus, and then it would be r minus 2, r plus 2, 52 over r plus 2. And that equals this product, and I'll simplify it a little bit by multiplying r minus 2 times r plus 2, which is r squared minus 4 times 4. Now looking at this, I can cancel the r plus 2 in the numerator, which is a factor, with the r minus 2 here in the numerator, with the r minus 2 in the denominator. I'm actually left with a denominator of 1. Over here, I can cancel the r plus 2 factor in the numerator with the r plus 2 in the denominator. And again, though I don't have to write it, I'm left with a denominator of 1. Now when I write this, I have 44 times r plus 2 plus 52 times r minus 2 equals, I'm going to write this as 4r squared minus 16. Now I have nothing in the denominator. They're cleared. So I continue solving. Multiplying, I have 44r plus 88 plus 52r minus 104 equals 4r squared minus 16. And then I can combine like terms. 44 plus 52 is 96r. 44r plus 52r is 96r. 88 minus 104 would be minus 16, and that equals 4r squared minus 16. And I can see that I have a quadratic equation here, and I'll do one more step on this page and then go to another page. I'll add 16 to both sides, and that gives me 96r equals 4r squared. Now to solve 96r equals 4r squared, I will subtract 96r on both sides, which gives me 0 equals 4r squared minus 96r. Notice that I don't try to divide by r here. Since it's a quadratic equation, I want to get a 0 on one side, and then I can factor. And I factor out a 4r, and I get 4r times r minus 24. Now I have a product. 4r times r minus 24 equals 0. So I can set each factor equal to 0. 4r equals 0, or r minus 24 equals 0. Solving those separately, I get r equals 0 here, and r equals 24 here. So I have two possible solutions, and I'm ready for step 4, which is to check the answer in the original problem. Let's go back to the original problem and see if we first of all have found what we were looking for. We're asked to find the speed of the boat in still water, and that was what we defined r to be. Now let's see if either of those makes sense before we check the numbers. Does it make sense to have the speed of the boat in still water to be 0? Well, if the speed of the boat in still water was 0 and we had a current, it couldn't go upstream at all. So r equals 0 is not a possibility. So let's check r equals 24. If the speed of the boat in still water is 24, then the speed upstream would be 24 minus 2, or 22 kilometers per hour. And the speed downstream would be 24 plus 2, or 26 kilometers per hour. Now, we know that the distance upstream was 44 kilometers. The distance downstream was 52 kilometers. How long did it take to travel? Well, the time upstream would be the distance divided by the rate, or 44 divided by 22, which would be 2 hours. The time downstream would be the distance downstream, which was 52 kilometers, divided by 26 kilometers per hour, which would give us 2 hours. The last thing we're told in the problem, the last piece of information, is that the total time was 4 hours. And since 2 plus 2 is 4, we do have a check. And we can state our answer, and that is that the speed of the boat in still water is 24 kilometers per hour.